The infrared thermometer, or IRT, is a device that measures temperature of an object from a distance. It relies on a type of radiation called infrared. Sir Frederick William Herschel was the first man to discover infrared radiation. He created and experimented with spectrums and what he called calorific rays, what we would call infrared radiation today. His experiments were important because it was the first time someone demonstrated the existence of types of light that we cannot see with our own eyes. The first commercially available IRT was introduced in 1931. Following World War II and throughout the Cold War, infrared technologies further advanced. Today, infrared technologies are everywhere, from cameras used by the military and first responders to infrared satellites to measure weather and climate change. And if you've been in any public spaces within the past year or so, I'm sure you've had a handheld IRT pointed at you before, which is used to measure your body temperature in a non-invasive manner. For my project, I thought it'd be cool to buy my own IRT so that I could learn more about how they work and have some fun too. My infrared thermometer was the Braun no-touch thermometer that I found at Costco. It came with instructions for using its two main modes, forehead scanning and water temperature reading, as well as uncertainty values and other important pieces of information. The IRT operates on a concept called blackbody radiation, the idea that all objects, including humans, emit heat in the form of thermal radiation at temperatures above absolute zero. Infrared is a type of energy that is a part of the electromagnetic spectrum, and although infrared can't be seen by humans like visible light can, we can still detect it and feel it as heat. Infrared radiation can be reflected, absorbed, concentrated, and measured, which is exactly what the IRT does. The IRT focuses the light coming off the object being measured in the form of IR rays and funnels the light into a detector called the thermopile, a device that transforms thermal energy into electrical energy. By measuring this electrical energy output, a numerical value is measured and displayed on the screen. That number is the temperature of the object. My IRT is set to measure in degrees Celsius, but there are other models that measure in Fahrenheit or even Kelvin. I should note something else too. All IRTs rely on the measured object's emissivity, the efficiency at which the object emits thermal energy. Different objects have different emissivities, so IRTs must compensate for these differences to get proper measurements. My model, unfortunately, doesn't have an adjustable emissivity setting. That's okay though. It just means that I should only use this IRT for what it was made for, measuring human body temperature and water. Measuring anything else would give an inaccurate result since it has a different emissivity. I designed two basic tests that compared my IRT to other thermometers. The first test measured human temperature, comparing my IRT's forehead scanner mode to an ear thermometer, another type of infrared thermometer that yields accurate inner body temperature readings by measuring tympanic temperature, temperature of the ear. My sister and I were the test subjects for the experiment. Taking 3 temperature trials with each thermometer, we collected enough data to compare the two thermometers' readings. Considering the uncertainty values for both thermometers, the results agreed with each other for both of us, and made sense when comparing to the average human body temperature. The second test compared my IRT's water temperature mode and a contact meat thermometer. First, I boiled some water. Then I took multiple readings of the water's temperature with both thermometers. The results I found were less than 100 degrees, which was the initial temperature, but this could be for many reasons. From the body temperature testing, the results found between the IRT and the ear thermometer agreed within their uncertainties. However, this doesn't necessarily mean that they're both accurate to our actual body temperatures. A study measuring temperatures of donkeys with multiple different thermometers found that IRTs aren't super accurate to the animal's core temperature. When comparing the IRT to the contact meat thermometer, the results did not agree. This highlights the main limitation of the IRT. Because it's contactless, it only measures the surface temperature of the object. Studies have shown that while the IRT is quick and contactless, it doesn't give perfect readings for this exact reason. This means that IRTs should not, and thankfully are not, the only method of detecting those potentially infected with COVID-19. Overall, the infrared thermometer is a quick contactless device that can give accurate measurements depending on the object being measured. There are more accurate thermometers out there, but the trade-off is that they take longer and require contact with the object of interest. Thank you for watching, and here are my sources.